Hello and welcome to Tuesday's edition of Cracking the Cryptic, where if yesterday was hot, today's even hotter. And I've just had to go out and do a load of chainsawing. This is just it's terrible. But I have returned indoors, and it's not cooler in my office at all. I've got the fan on today. There might be a tiny background noise compared to usual, but I really couldn't. I don't think I could manage to record without the fan being blasted on me, so I apologise if there is a tiny bit of background noise that's a bit different to usual. But we're going to be having a look today at Balanced X Sums, which is a brand new puzzle by the American math teacher RockyRoer. RockyRoer, who first featured on Cracking the Cryptic with a puzzle, I want to say in about August 2020. So almost at RockyRoer's 6-year anniversary of first appearing on the channel. And well, I think this is a new puzzle, but we've already had lots of emails saying we have to have a go at this. Apparently it's got a little bit of sort of arithmetic in it, nothing monstrous, but the feedback that we've been receiving says if you like a tiny bit of arithmetic, this is an absolutely gorgeous puzzle. And it's got 3 stars out of 5 for difficulty. So we'll read the rules. You can see it's a very sparsely populated grid today with just some arrows out. So can I click? No, I can't click on the arrows, but just some arrows outside. Anyway, we'll read the rules of this one in a moment or two's time. I've got some things to mention before that. Let me start by saying many thanks to those of you who joined us last night when we streamed the blueprints again for the 46th time, I want to say. And I won't spoil what happened. I do think it's probably worth watching if you have been following our journey and you missed the stream. So I will try and remember to put a link to the VOD on the screen now. And a reminder, if you are following this series, next week's edition is on a different day. We are streaming on Sunday night at 10 p.m, not Monday night at 10 p.m. And the reason for that is that Steam have asked us to be part of what they call the Cerebral Showcase, which is where some streamers basically stream games that involve puzzles over a whole weekend. So we are going to be closing the show, that's the right way to describe it, at 10 o'clock on Sunday night. If, as I say, if you do enjoy the blueprint streams, please don't be disappointed. Don't be disappointed, and make sure you note it's Sunday night this coming week. Now, what else can I tell you about? I would like to mention the winner of May's competition. Mark has used his random number generator and tells me that the winner of May, drum roll please, is Michael Stranieri. So Michael, I hope you're watching this. I will be writing to you to see whether or not you might be interested in coming onto the channel and solving a puzzle and hopefully appearing in a video. Very, very well done. Very well done to all of you. There were hundreds and hundreds of you who managed to solve all of May's competition. I can tease June's competition, obviously with the release in the US of all the classified files related to alien life on Earth. We've been going through those files and we've noticed some interesting puzzle-like content. So there's going to be an alien discovery type theme based off those, definitely the real US files, coming on the 1st of June. So do get involved. Make sure you're a patron by then, and that competition will go live at 4 p.m. on the 1st of June. Now, what else? I would like to say thank you to Preston. Actually, have I got Preston's... let me just see if I can find it here. Preston's email, which was very kind. Let me just... I'm not very well prepared for this. But Preston wrote to us from across the pond, and to say that I think Preston has now been watching the channel daily for 27% of his life, which is quite a lot. Even going back to the Dueling Dragons video, that was Icy Fruit, wasn't it? Which, well, I'm not sure I can say anything about the video, but I do remember the puzzle. That was an extraordinary puzzle by the by the rarely seen Icy Fruit. Icy Fruit, if you ever watch the channel and you're watching this one, I'd love to see another puzzle by you, my friend. But anyway, Preston just wrote a kind email saying that the channel provides a good laugh occasionally at our expense and some mental exercise. And yeah, it was one of those emails that made me smile. So I wanted to shout you out, Preston. Thank you for that. I have no birthdays to do today, which is most peculiar on a Tuesday. And I think that, therefore, is all the news, which means that we can have a go at doing some solving. Shall we have a go at Balanced X Sums by RockyRoer? What do we have to do? It looks like normal Sudoku rules applying. So we're going to have to put the digits 1 to 9 once each in every row, every column, whoa, and every 3 by 3 box. Now, Balanced X Sums. Each arrow indicates that the sum of the odd digits must equal the sum of the even digits in the first X cells seen in the direction of the arrow, where X is the digit in the cell next to the clue. So what does that mean? Let's put 5 in there and see if we can understand it. So 5 would be saying, look at the 5 cells nearest to the clue. Okay, and the sum of the odd digits in those purples would equal the sum of the even digits in those purples. So that's quite peculiar, isn't it? I'm trying to think of a way of doing that so that it works. I think you could put 7 in. 2, 4, 6, something like that. 2, 4, 6 is 12, 5 and 7 is 12. I think that would be a way of completing that clue. I'm going to claim. And no, I can't scroll. So that is it. They are all the rules. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Now, I say let's get cracking, and I have absolutely no clue. Do we think it's going to be... Do we think there's going to be a constraint where arrows point at each other? Okay, all right. One trivial thing we can say is that using the secret, we can... None of these arrow clues can have an... Actually, this might be important. None of them can have a 9 in their first position. And that's because, now this is a secret I share with only my very favourite people. I'm sure RockyRoer knew the secret already. And if you're watching this video, you're definitely one of my favourite people. So I'm going to share the secret with you. The secret of Sudoku is that all 9 digits in any row, any column, or indeed any 3 by 3 box, we know the sum of them. Because we know that any row, column, or 3 by 3 box contains the digits 1 to 9 once each. You sum those digits, you get 45. Now, one of the things that I can grok immediately from this rule set is that because the sum of the odds is going to equal the sum of the evens within any X sum clue, the total must be even for that clue. It must be. Because you're essentially adding X's worth of odd digits to X's worth of even digits. So the sum of any X sum clue is 2X, which is even. So 45 is odd. So 9 is impossible in any of these arrow clues. I mean, 1 is trivially impossible as well, because obviously if we put 1 there, we're saying that within that 1 cell, the value of the odd digits, which is 1, is equal to the value of the even digits, which is 0. So that's definitely wrong. 2 won't work either, will it? Maybe we're going to have to actually work through this and see how it... 2 won't work because this would have to be a 2, but it just wouldn't work. Those two have to have, well, the odd digits in those 2 cells have to equal the even digits. It's just nonsense. Now, what about 3? Does 3 work? 3? Right. Okay. Here is another principle that we can establish. The sum in any, let's just delete 3 for a moment. Whatever the length of the X sum is, there's going to be some odd digits in the x sum. Now, there's also going to be some even digits. What's the sum of the even digits going to be? Well, we might not know the quantity, but we know the nature of the sum. Because if you sum even digits, what do you get? You get an even number. So, how do you create an even number out of the sum of odd digits? The way to do that is that you must have an even number of odd digits. If you had 3 odd digits and you added them up, you would get an odd number. But if you had 2 or 4 or 6 or 8, you would get an even number. So each x sum must have an even number of odd digits in it. So when we go back to thinking about 3, we know that the remaining, we're going to need another odd digit in order to make the odd digits sum to an even number, and 1 even digit. So we could do 1, 4, that would work. We could do 5, 8, that would work. 5 plus 3 would equal 8. We can't do anything else because 7 plus 3 is 10, and that's too much for the even digit. We can't put a 10 into any cell of the Sudoku. So 3, well, fundamentally 3 is possible, so it doesn't have the nature of 1, 2, and 9. And then 4 is going to have 2 odd digits in it. Again, it's got to have an even number of odd digits. Okay, let's do a table. So we're going to have the x number, the number of odd digits, the number of even digits, and see if we can find a pattern. So we're going to, 3 is the first one. That's got 2 odds, 1 even. 4 is going to have 2 and 2. 5. Now 5, you can't have 4 odd digits, because 4 odd digits will add up to 1, 3, 5, 7, which is 16. I can't write 16 into a cell. So that's going to have 2 odds and 3 evens. What's the minimum sum of 3 evens? 2, 4, 6, which is 12. Now that is achievable. Okay, don't know, 6. So 6 is either going to have 2 odds or 4 odds. So it can't have 4 odds, because if it's got 4 odds, actually, that's interesting. It also can't have 2 odds. Well, that's not strictly, we might have to be careful with that. Ooh, right. We're going to have to be careful with this one. 6. Can it be... Oh, hang on. I am going to have to be careful because I've just noticed there are diagonal clues, and I've just been assessing this from the perspective of clues that can't repeat digits. I've got bits of tree in my hair. That's yeah, okay, well, sorry, I'm gonna now slightly change this. I'm going to say this table is for horizontal and vertical x sums only. I'm not sure about this one, where you can repeat digits. There's a few of those, actually, isn't there? There's 3 of them at least. So let's think about 6 if it, say it was in this row. Now, what we can say is it can't be 2 odd digits. Because if it was 2 odd digits and 4 even digits, those 4 even digits would all be different. And I know that the 4 even digits in Sudoku sum to 20. 2 plus 4 plus 6 plus 8 is 20. So that's not going to work, so I can't make 2 odd digits sum to more than 16, 9 plus 7. So that doesn't work, which means it would have to be 4 and 2 the other way round. But here we get a different problem. The minimum sum of 4 odd digits, if they have to be different, is 1, 3, 5, 7, which is 16. And I can't make 2 even digits sum up to more than 14, 8 and 6. So 6 doesn't work, which is very strange. So 7, now 7... Again, if we're just thinking about a row, It can't be 2 odd digits because there'd be 5 even digits in the row, and there are only 4 even digits in Sudoku. So it's going to have to be 4 odd digits and 3 evens. Now, does this work? 4 odd digits are going to sum to a minimum. Well, all the odd digits sum to 25. So a minimum of 16. Oh, no, you can do that. Because the 3 even digits will sum, well, they can certainly sum to 16. In fact, they're going to have to be 5 different. That's weird. That is a weird thought I've just had. Yeah, okay, here is a thought. So, in Sudoku, there are 5 odd digits and there are 4 even digits. Now, the nature of a 7x sum clue is saying I'm going to remove from the odd digits 1 of them, because we've only got 4 out of the total of 5. And the even digits, I'm going to remove 1 of them. So I'm only going to have 3 instead of the total number we could have, which is 4. And yet somehow, the sum of those has to be the same. But the natural sum of the odd digits is 25, and the natural sum of the even digits is 20. So the digits that I'm sort of going to be playing around with, I'm going to have to make sure that the odd digit I take out, I don't include, is 5 more than the even digit I don't include. So it's either 9 and 4 or 7 and 2. And it's not 7. Oh, that's just so beautiful. That's beautiful, actually. That's my favourite one so far. That's absolutely beautiful. So 7 only has one way of being concocted. Because you have to have 5 difference between the outies, if you like, the digits you're leaving out, because you're sort of trying to correct a sum of 25 and a sum of 20 by removing 1 digit from each of those such that the totals are the same. You're going to have to, you could remove a 9 from the odds, that gets you to 16, and a 4 from the evens. Or you could remove a 7 from the odds and a 2 from the evens, but you can't remove, if we had a 7 here, and then we said, okay, we're going to leave 7 and 2 out, you'd have a 7 and you'd have 7 repeated in the column. You can't do that. So 7 only works one way, and that is you leave out a 4 and a 9. So this one is this one is the most restricted one so far, I think. I certainly didn't notice any restriction when we thought about 4s and 5s of that nature. Let's think about 8. So 8, we know you can't have a 9. Oh, 8's easy. Yeah. 8's going to have to be 4 and 4. Because, well, we need an even number of odd digits. So we can't only have 2, because we can't have more than 4 evens, if you see what I mean. But that means we're using all of the even digits, which sum to 20. So the odds are going to have to sum to 20. And by the secret, therefore, the digit left out of an 8 clue in this puzzle will be a 5. So if you put an 8 there, that would be a 5. So 7 and 8 are the most restricted, I think. And 1, 2, 6 and 9, if we're not talking about diagonals, simply can't exist. So what we want to do is find, it's nearly, well, no, I can actually do that in this column. Because this cell can't be 1, 2, 6 or 9. I mean, the arrow's going vertical, but it's still the same principle. That can't be 1, 2, 6, 9. That can't be, that can't be, that can't be, and that can't be. So those digits have to be 1, 2, 6, 9. And we can do the same in column 1. I just didn't see it. You've got a vertical clue, but in both of these positions. So neither of those can be 1, 2, 6 or 9. Those can't be 1, 2, 6 or 9. So these are 1, 2, 6, 9. Now in this row, these can't be 1, 2, 6, 9. No, that one can be. So there's 5 for the 4 digits there, and the top row is useless, isn't it? So this clue can't be 8, because we knew 8 had to have a 5 across from it. Yeah, okay then. If you've been watching the channel for a while, you're going to laugh at me for this. But I'm actually going to fill this in. 3, 4, 5, 7, 8. Now what we learned before, what we learned when we were doing the examples is that 8 and 7 were the difficult ones to place. Because they had to, 8 had to have a 5 opposite it, and 7 had to have sort of a 4-9 pair. Okay, yeah, that's good. So 7 can't be there or there. That's wrong. That's wrong. Sorry, didn't see it. It absolutely could be there, because that could be a 4-9 pair. Bobbins. That can't be. Because if this was a 7, we know the other side of the column would have to be the 4 and the 9, and they can't be 4, 9, so that can't be 7. That could be 7. Oh dear, this, hang on, this is, I'm not making a good fist of this at all. 8, if you put 8 in, it had to have 5 at the other end, but that could be a 5. Those could be a 5-8 pair, I think. How did 3 work? 3 was either with 1, 4. Okay, no song for this cell, because if this was 3, those two cells would either be a 1, 4 pair or a 5, 8 pair. 3 plus 1 is 4, 3 plus 5 is 8, and that's neither of those that's possible, so that's not 3. And what about this one? That can't be, that's the same. That can't, this cannot be 1, 4 or 5, 8. What about, no, that one could be, that's only pointing that way. This one, that one could be. That could be 3 with a 5, 8 beneath it. Bobbins. Bobbins. Okay. It's quite tricky, actually, isn't it? Even though we've done some thinking. I mean, I've got a horrendous sequence of pencil marks here. I'm desperately looking around saying, where is restricted? Oh, that can't be 8, because this can't be 5. That can be 8, because that can be 5. That can be 8, because that can be 5. That can't be 8, because this can't be 5. If that was 5, we'd know the sums, because we'd be summing those. We know that's a 1, 2, 6, 9. No, that doesn't work at all. Yeah, look at that. I'm saying if, oh, that's a horrible colour, actually, choice. If this was a 5, then the 2 even digits. Well, no, hang on, there should be 3 evens. It doesn't even work from a parity perspective if this is 5. Because you'd actually be adding 3 odd numbers. You'd be adding 1, 9 and 5 together. So you're going to get an odd total. That's just absolute nonsense even before you get to the arithmetic. So this digit's actually very restricted. Can that be 5? If that's 5, I've got to have a second odd digit and 3 even digits. Oh, the 3 even Oh, that's lovely, actually. No, that doesn't work. Right, the way to see this is parity again. If you make this an 8, we know 8 goes opposite 5 because we're summing those 8 digits up, and we know that we need a 20 total for the evens and a 20 total to the odds. So you've got to have a 5 here to make the column add up. Now you're summing these digits and you're trying to equate the odds and the evens. But we know that we need an even number of odd digits in these green cells, which means we need 3 even digits, not including 8. So we know that those digits need to include 2, 4, and 6. Well, they can't. Where's the 6 going to go? This one could be 2 or 6, but it can't be both. And none of those can be anything other than 4 if you want them to be even. It just doesn't work. So this is good. This is going to get us our first digit, which is going to be this one. That is a 4. So these are not 4. And now we're summing those 4 up to be equal to something useful. So we need 2 odd digits. Oh, there you go. You need 2 odd digits in that sum. Well, what are those odd digits going to be? They're going to have to look at the options. They're going to have to be 1 and 9, summing to 10. So you're going to need a 6 with those. So this is a 2. This is lovely. Right, that's not a 2 by Sudoku. That's not a 4 by Sudoku. Now, so there's a diagonal one there as well. That's a diagonal clue. But I think the diagonal clues are going to be horrible because you can repeat digits on them. You know, there's nothing to say this can't be a 4. I mean, there might be some Sudoku reason I'm not noticing, but I think that could be a 4. Oh no! So what do we do now? I don't know. Right. Here is a tiny point. This 4 has removed the ability of these cells to be 4. Therefore, I'm going to allege, I think correctly, that none of these can be 7. Because we know that 7, on the other side of the row, you're going to get a 4-9 pair. So I don't think that's going to work anymore, because none of these can be 4 or 9. So is there a reason? Now that can be 7. Bobbins. I was going to say maybe that can't be 7. Then I would have known this was 7. I'd have known this was 9 and this was 4. But that can be 7 because I think that can be 4, 9. Oh dear. Can that be 5? We're going to know the sum. Yeah, let's think about that. If that's 5... No, there aren't enough... No, sorry, that's not 5. There aren't enough even digits in that sequence. There's 2 and 8. There need to be 3. Oh. And now whatever I've been cutting down outside is giving me hay fever. Ah! So that's 3, 7, or 8. Oh, it's not 8. I can see that. Because if that's 8, that would be 5. So this is right down. This is down to 3 or 7. Now, if it was 3, that would have to be 5, 8. And this would be 7. Oh, it nearly doesn't work. That would be 7. This would be 4. This would be 9. But if that was 7, that would be 9. Oh no, I was thinking if that was, there is a diagonal clue there as well. So if that was 3, this would have to be 5, 8, and that would have to be 1, 4. But that could be true. Oh, Bobbins, I don't know then. How do we do this? 8 has to be in this column in one of those 2 cells. So we know 8, because 8 is in one of those two is 5, because 8 must be opposite 5, so that's not 5 in that corner, or 5 here, or 5 here. So that one's come right down, that's 7 or 8. I'm just going to quickly, do that, just to say there's an 8 in one of these and there's a 5 in one of those. I don't want to do that because I'll forget what it means. No, oh no, I was going to say where's 7, but that doesn't work. Wait, that can't be 8 because that can't be 5. Hang on. That's okay, that's really cool. So actually, this 8 here, it's bizarre. It doesn't, because it puts 5 in one of those two, it doesn't just get rid of 5 from that cell, it also gets rid of 8 from it, because we know 8 would be opposite 5 on the other side of the grid. That's lovely. That's got to be 7. This is huge. This is absolutely huge, because now, well, no, it is huge, because those have to be 4, 9, and we know the order. So these are not 4. This is 3 by Sudoku now. So these are now 5 and 8. And that 4 has to be the sum of those, look. Let's use that colour. This 3 has to be the sum of those. Oh, lovely. That 3 can't be 5, 8 there, because that would kill off this square. So that's got to be with a 1, 4 pair, which means this is not a 1 or a 9. That's just a naked old 6 sitting there with a 1, 2 pair here. This is not a 1. One of these is 8, so one of these is 5. So that's not a 5. So I've got a 3, 7 pair now in column 1. It's absolutely beautiful. Oh no, that's okay. I was going to say I've got a deadly pattern of 5s and 8s there, but it's not really deadly, is it? Because contrast that to this situation. Now that would be deadly if that existed, ignoring X sum clues, because you couldn't determine whether the 5s would be there or there. Either way round, you'd still end up with 2 5s in every row, column and box of the grid, and 2 8s in those columns as well. But this, if that was a 5, for example, it would disambiguate all of that sequence. So this isn't deadly. But, okay, it's fine. It's fine. This can't be a 3 in the corner now, because what would we put into those two cells? We know these, if this is 3, this should be 1, 4 or 5, 8. And they can't be those, because that one can't be 5 or 8. So that's got to be a 7 in the corner with a 3 here. Now this, this 3 clue can't be 5, 8. So that's got to be 1, 4. It's the same as that one. And that's, oh, the 7 clue. In the column, we know 7s, just as we did here, go opposite 4s and 9s. So this is lovely. That's 9, that's 6, that's 1, that's 1, that's 2. This is a beautiful puzzle. It's. I know exactly what those people who've recommended it mean. It's sort of, it's just got a gorgeous sort of underpinning logic to it. Now that's 7. We've got diagonal 7s pointing at each other here, which is a bit weird. Let's put that in. I mean, that's horrific, isn't it? That is horrific, because there could be so many repeated digits on those diagonals. So what have I used? All the clues that we've been given here, or is it Sudoku? 1 has to be in one of those 2 cells, because it can never be a clue cell, can it? These 2 clue cells have to be, I'm going to say, from 3, 5, 8. We know they can't be 1, 2, 6, 9, and they can't be 4, 7. So these are from 3, 5, 8. Now, so if this was 3, this would have to be a 5-8 pair. If it's 5, you've got to have you've got to have 2 evens. No, you've got to have they've got to have 3 evens. I keep thinking 5 the wrong way round. You've got to have 3 evens. So they'd have to, in that situation, it would have to be, because you can't put 2s in any of those cells, it would have to be, this is 5, it would have to be 4, 6, 8, which is, it doesn't work. It doesn't work at all. The 5, oh, I tell you something I hadn't realised when we looked at 5 earlier. 5, a 5x sum clue has to have 2 odd digits and 3 even digits. Now, if those 3 even digits didn't include a 2, it wouldn't work, because 4 plus 6 plus 8 is 18, and you can't make 2 odd digits sum to 18. So there is always a 2 in any 5 clue. So this is not 5, because those can't be 2 and that can't be 2. So can that be 5? You could have a 2. Yeah, that's easier. That's a lot easier. Although, can that be 2? Because that would make... No. If that's a 2, this 4 clue would break. Because these 2 digits would have to be 2 odd digits summing to 6. And they can't be double 3 or 1 5. So that is not a 2. So if this is 5, that is a 2. I don't think that's a problem. Is 5 restricted in some more meaningful way that I'm not understanding? Can I just think about 5 a bit harder? So 5, it's 2 odd digits. I keep getting this wrong. And 3 evens, including a 2. So it could be 2, 4, 6, which is 12. Can I make 2 odd digits sum to 12? I can in 2 different ways, 5, 7, or 3, 9. Oh, but I can't use... No, I can... No, but I'm using 5 in the clue. So it would have to be 5, 7, 2, 4, 6. Right, let me just write that down. So one option for 5 is 5, 7, 2, 4, 6. Wouldn't work in that row. Now, what about if we went higher than that then? 5, 9 would be the only other way of doing it, because we know the 3 evens must add to at least 12, and we know one of the odd digits is a 5. So 5 and 9 is 14. So 2, 4, 8 is the other one. So 2, 4, 8, 5, 9 is the other one. So there are 2 ways of doing 5s. And they both have 4 in. And they both have 2 in. Okay. Bobbins. I don't know. How am I meant to do this then? Is there any way to see how this works? I don't know. Okay, they both have 2 and 4 in, and 5. 4 in that row is in one of 3 places. So whichever one of these is 5, is going to need a 4. So one of those is a 5. And it's going to need a 2. So if that was a 5, 2 would be in one of 2 couldn't be in one. There you go. There's some. That's it. That's actually it. Okay, so look at what we have to do is a bit of Sudoku, but not much. There's a 2 here. Now where's 2 in box 6? It's in one of those 2 cells. Now, can this be 5 then? No. Because in those 5 cells, we'd need to have a 2 to make the maths work, and we can't have one because of this. So that's got to be the 8. So 8, 5, 5, 8. Now I think the 8s are going to be particularly useless from that. We're not going to get any more information. But the 5s we do have some more information to gain from. For a start, this 5 needs a 4 in it. So that 4 must be in one of these 2. This 5 needs a 4 in it, so that's got to be in one of those 2. And this one, this 5 can't have 8 in it, so it must be 2, 4, 6, and 5 and 7. So I know what these digits are. They are 2, 4, 6, 7. And this has not got 4 in it, or 6. So this is a 4, 6 pair. It's very, very beautiful, isn't it? Now they are 8 and 9, therefore, by Sudoku. And these digits are 1, 3, 9 by Sudoku. And it's the same logic in this row. Because the 8's on the other side, we can't use that option that was the 2, 4, 8 for the even digits. So here we're also using 2, 4, 6 for the evens, and the extra odd digit is a 7. So this is not 4, 7. So this is 4, 7. This is 2, 6, and let me guess that's 8, 9, and it is. Right. Now. Yeah, and now this 4 clue comes into its own. Because what's the other even digit we're going to put into this 4 clue? It can't be 8 anymore. Now if it was 6, we'd have 2 even digits summing to 10. So the odd digits would have to either be 1, 9, nope, or 3, 7, nope, that doesn't work. So they have to be 1, 5, 2. 4 and 2 is equal to 1 plus 5. And these have to be 6 and 3. Now there is a 3 in one of those. What are those digits? So they're 1, 3, 9 again, aren't they? It's exactly the same as the row beneath it. Okay, and they can't be 9 by Sudoku. So this is a 9. This is a 1, 3. So this is 2, 5, and that is a 1. This is gorgeous. It's just gorgeous. Right, what are those digits then? 6, 7. No joking. That's a meme, I'm sure, that RockyRoer has come across once or twice in the classroom. 2, 8, 5, I think. Does that look right in row 2? I think so, by Sudoku. Okay, so let's once we've got a clue, we should uncolour it to make sure that we don't rethink about it. So we haven't done this clue. We haven't done these 2 clues. Oh, that's a very dodgy sound outside. What does this mean? So if this was 8, that would be 5. This can't be 8 anymore. Can't have a 5 above it. So this is 3 or 5. So if it's 5, what do we work out? It had to contain 2 and 4. So it would have to be... No, it doesn't work. It doesn't work. How to explain that? If this was 5, we'd be summing these up. And what we said earlier is that whenever you have a 5 clue, you definitely involve the digits 2 and 4. And then you either have a 6-7 pair to go with that, or you have an 8-9 pair to go with that. So have a look at this column now, and let's think how that works. If this was the 2-4-8 5-9 variety, that cell can't exist. And if it was the 2-4-6-5-7 variety, that cell can't exist. So this has to be 3, I think, and we can shorten our length of green. Now those two digits don't involve 1, so these aren't 1-4, so they're 5-8. This is gorgeous, isn't it? So that's now a 2 up here. Oh. Okay. Okay, maybe that... Oh, this is an 8 now. That's going to do something up there. That we know 8s go opposite 5, so that gives us a little bit more Sudoku to benefit from. Look, that's 7, that's 6, that's 8, that's 9, using the power of this 8. And we've done those clues now, so they don't earn colours. So we have now almost finished all of the... It must be Sudoku, or it's either Sudoku or these remaining coloured clues, but they seem very underpopulated to me. So I'm slightly too scared of them to try and work them out. Can we do any more basic Sudoku? Let's think about that. Probably. Although I don't exactly see where. This is 3, 5, 8. Oh, that's a 3. So there's a 6 at the top of column 4. So 6, 3. That isn't 3. There's no X sums clues at the top of columns 4, 5, or 6. So these digits are from 1, 9, 4, 7. That can't be 9. So this is a 1. This is from a snooker maximum. That can't be 1 or 4, actually. That is 7 or 9. Maverick's just taken off. Must be a hot day to be Maverick today. 1. I can do 1 in the bottom row. It's got to be there. So one of these two cells is a 1. Okay, let's look at the bottom row then. 2, 5, 6, 9. Can we... let's pencil mark it. 2, 5, 6, 9. Can we do... We can. Where's 9 in the bottom row? There's enough 9s that we can take care of business there. So this becomes a 9. This can't be 5 because of this 3, 5, 8 triple. So that's 2 or 6. 5 is definitely in this domino. It's probably this clue, isn't it? Because at least we've restricted this row 6, column 4 a little bit. Well, okay, what's the even... Yeah, this is fine. What's the even digit that's going to accompany the 4? It's definitely not a 2, because that's already going to swamp it, because we'd be trying to add the 2 odd digits to 6. Now, actually maybe we could do it. Okay, so if the even digit here is a 6, then we know this would be a 7 with a 3. So this would be a 3-6 pair. Now, is there a reason that doesn't work? Not sure. I don't think so. And if the even digit, on the other hand, is 8 in these two cells, then the odd digits are adding to 12. So it'd either be 7 with a 5 in one of these, or 9 with a 3 in one of those. Oh, bobbins. That seems completely open-ended then. Oh, I'm sorry. I don't think that is how to do it then. Okay. All right, I'm gonna change tack entirely. I'm going to do 3 by Sudoku in the middle box. There, I've said it. It goes there. So we need 1, 4, 5, 7. 1, 4, 5, 7. That's a 4, 6. So that is not a 4 there. So this is that's weird. Oh, I see. No, simple question. Where's 4 in column 4? That's been available forever. That's 4. That's 7. So in box 5, what digits have we not placed? 2, 5. Is it 2, 5, 8 again? That's quite handy. Oh, that's really handy. That is really handy. 2, 5, 8. That digit sees 2 and 8. That's got to be 5. That does the 5 and the 8. The 8 and the 2. So Sudoku has suddenly come to our rescue for once. This is right. Now what do we need in this row then? 1, 4, 7 again. 1, 4, 7. With the 4 definitely being over here. And in this row, 5, 7, 9. With the 5 definitely being over here. 7, 9. Okay, let's check out column 5 then. What do we need there? 4, 6, 9. Yep, where's 9? We can do that. That's got to go there. And in this column, it's slightly less populated, isn't it? 2, 4, 6, 7. 2, 4, 6, 7. And that can't be 2. Now, what, if anything, does this tell us? I don't know. I'm not sure. Oh dear. I don't want to look at these. These look really complicated. I think we're going to have to, though, aren't we? So how's this going to work? It must be subject to the same principles. We've just got to be careful with the fact that we've got repeating digits. So, for example, a 7 clue. It is going to have an even number of odd digits. So it's going to have, I'm going to claim. Well, actually, look. If we look at this top left clue, that's already got. That's definitely odd. That's definitely odd, and that's definitely odd. That's 3 odd digits. That's not enough. There must be 1 more odd digit. Because we definitely can't make 6 odd digits work. Because they would have to add. Oh well, there's 2 even digits anyway. It just wouldn't work. So the indigo 7, this one, has got 4 odd digits on it, which are that one, that one, that one. I wonder if that can be 9. That would be 21 for those 3. So at least 22. I think it could work. No, actually, no, it can't. Hang on, I'm not sure. I'm not sure, actually. No, it actually can't work. That's weird. That's a bit tricky. Okay, so what we're going to do is on the indigo clue, I'm going to change the colour of this. And change the colour of that to green. Let's label the odds. Those are definitely odd. This one could be odd. This is definitely even. This is definitely even. That one could be even. This one could be even. So let's try and max out the value of the evens that we could possibly have. We could have a 6 here, an 8 here, that's 14. But this can't be bigger than 4. It sees 6 and 8, and that can't be bigger than 4. So the absolute maximum value of the evens on the indigo diagonal is 6, 8, and another 4, which is 18. So if this was 9, you'd never get big enough, because that's already 21 for those 3. So this is 1, this is 7, this is 9. Now, hopefully that will do something Sudoku-wise for us. It might affect the green clue. Yeah, we can't have 6 here anymore because it would need 1 9 to match it off, which won't work. So we're going to be looking at 4 8 adding up to the same as 3 9. So this is a 3 8. Ah, it doesn't quite do it. This is a 3 8 pair. That's incredible. That hasn't actually done it at all. All right, let's go back to this again then. So at the moment, our odd digits are adding to 13. We've got 1 more to come. I don't know where that is. It could be here or it could be there. If that is even, it has to be 4. And that would, okay, so if that was true, this would be a 1. We'd have 7 5 1 and another 1. 14. 8 4, and that would be 2, and that would work. Bother. I mean, there might be a technical reason it doesn't work, but it's certainly not obvious to me what that is. Okay, let's have a think about that. I haven't thought about this clue at all. Now that clue, that's definitely got the same odd. It's got the 1 and the 5 in box 5. It's got that one's definitely even. That one's definitely even. So there must be 1 even. This must be 1 even and 1 odd. Okay. I'm going to have to pencil mark them, aren't I? I don't want to do it, but I think I'm going to have to. Right, let's check this one out first. 1 3 4 6. Okay, so 3 4 or 6. It can't be 1. So this is also 3 4 or 6, therefore. Just from the column logic. In this column, 1 3 4 5. So these are both 3 4 5. Now, what on earth does that mean? That's the question. How on earth do you do this? What you can do, if that's odd, yeah, that's quite interesting. If that, let's just think about if this is odd for a moment, because there is an interesting thing that happens then with the 2 7 clues together. If this is odd, so let's just label it odd for the sake of example. You can then see that the odd digits that are counted in this clue are going to be the 7, this 1, this 5, and that digit. But it's the same here. It would be the 7, this digit, and that digit. So the odd digits for both of these clues would sum to the same number. So the even digits ought to sum to the same number. And from this one's perspective, the even digits are then going to be this one, and that digit. And from this one's perspective, they're going to be that one, and that digit. Now, because those are common, that means that digit and that digit would be the same, and they would both be 4. Now, okay, that does do something. It might not be much, but it does something. So what we've just demonstrated is that if this is odd, both of these digits have to be 4 for both 7 clues to work. Now, the other alternative is that this is not odd. And if this is not odd, it is 4. So in this box, 4 is either there or there. So 4 has to be in one of those, and those are not 4. Right, and now I've got a 3, 5, 8 triple in that row, which means this is not 3, so that is even now. That is great. That is great. That is actually, that sequence was great because this is now so beautiful. This being even, let's look at this clue now. We now know that there are 4 odd digits on this for this clue, and they have to be that one, and that one. So we are in a situation where this is odd. So this is odd, which means these 2 digits are the same. Let's just go through that again, just to check that we agree that these 2 cells have to contain the same number. So the even digits on this one are that one, and obviously this one. But the odd digits are that one, and that one. And the odd digits from this one are that one, and that one. So they're completely common because the 7s are the same. And the even digits from this one's perspective are that one and that one, plus 1 more, which is this one. But those 2 were in this clue. So these have to be the same digit, and they have to both be 4. And that's a 1, and that's a 1, and that's a 4. And that's going to do some stuff over here, look. It's going to do lots of stuff. 6. 6 here as well. 6, 4. 2. So I've got a 4-7 pair which is resolved actually. And this 3, 5, 8 thing, what's that doing? Where's 2? Right, 2's got to go there. So that's 2 and that's 6. That's 6 and that's 5. That's 5 and that's 7. These 2 digits now are, what's that? That's a 7 by Sudoku. That doesn't, so it's maths, is it now? Do we have to make, I have to make the diagonal work. Okay, so how do we do that? Let's use this clue. This clue tells, well, let's do the evens. We've got 18. So 12 and 1 is 13, so that should be a 5. So 5, 3, 5, 8, 8, 3, 3, 9, 9, 9, 8. That is such a lovely, lovely finish. Wow. Wow. Absolutely beautiful. It almost got harder as we went through, actually. I love the fact that there are some weird discoveries to be found. Like 6 doesn't work as a clue. It's not obvious at all. And you can then play around and get some stuff done. But actually that bit, the 7s bit, was gorgeous. This is a brilliant puzzle. RockyRoer, it's lovely to see you again. Let me know in the comments how you got on with the puzzle. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.